Hello, everybody. Today we have our first episode, and we are so lucky to have Ray as our guest. Ray is a chief architect at Alliance AI, and over the years he has made a lot of contribution to the legacy code field, and we can try to point out some of them. One of them is being an author at Mender AI, where he share his opinions and his reflection on evolving existing large systems. He is also the author of the Mechanized Mending Manifesto, where he explains how we can combine, the strong points of humans, algorithmic approaches, and AI to deal with legacy systems and large systems in general. But he also, at the cost of the podcast Empathy in Tech, where he focus on the human aspects involving software development and maintenance. And hopefully I will learn things of true from his experience running a podcast. And then there is also his website, Craft versus Craft. Am I pronouncing it sort of correctly?
Mm-hmm. Yeah, craft versus craft.
Good. And maybe we can start by mentioning one of the statements that you shared. That is that the future of software is the future of software maintenance. So, can you tell us more about this, please?
Yeah, this was part of my call to double down on our values. And when I say, us, I think of the legacy code community. I would say that the Mender community is what in particular came out of Legacy Code Rocks, and my co-host of the podcast you mentioned, Andrea Goulet. And these are people, we are people who see the challenge of software development being kind of centralized on maintaining and extending existing systems. The interesting thing about software is that you can change it over time. And this is a response in some ways. And I think it's a response that we need to really double down on. But it was always the case that writing greenfield projects, writing new code, is what gets all of the focus and the glory. And the problem with that is that new code becomes old. So no matter how important your new code is, if it is any good, we're going to have to worry about it in 5 years. And so if we are bad at maintaining old systems, which I contend we are, comically bad at it, then no matter how good we are at adding to the pile, we're still going to be in a bad place. And that is a conversation we need to reignite in the AI age. However AI impacts or accelerates software development, if we use that same misguided value of only thinking about how we can add to the pile and not how can we take care of what we have, then we're just going to make the situation worse instead of better.
Definitely, I can see the point, but I have sometimes the impression that when I ask one of my colleagues to work on a software project, and it feels like working on something new, feel like giving them a prize, while working on maintaining and fixing and evolving something existing is sometimes perceived as a chore, while the value is on the
Mhm.
teams that are out there producing value. But it's difficult to communicate that. Good. And something that surprised me when starting to participate in Legacy Code Rocks and reading more about the mending community was that maybe there was an understanding of what is legacy code that is wider than the one that I had. In my
Mm.
mind, at some point, legacy code was code that is written in legacy languages, stuff like COBOL, RPG, and everything else is not legacy. So maybe can I ask you, if you have a similar view or if you think differently, and which programming languages you have worked with you consider worth mending, if you want.
Yeah. I think the scope of legacy code and mending is all encompassing. Um, it might have been Arlo Belshi that defined legacy as any code that's in production. Like if your business depends on it now, it's legacy code in some sense. Now, some people use the term in this way to describe the stuff that's particularly old or particularly troublesome in some other way, and um, I guess they differentiate between like, oh, this is the code that needs to be rescued or retired, and then this is the code we think is kind of still in the greenfield space. I don't find that distinction useful. I think that calling out some of the production code as the legacy code kind of shields you from the reality that you're making tomorrow's mistakes today. You're adding to that pile. So I think of it as more just a continuous evolution. Um, so that's been kind of a conscious rebranding. I'm glad you've picked up on that, of saying, hey, everything that we leave behind is our legacy. We can't just say, oh, this isn't legacy code because it's in TypeScript instead of Java or something like that.
Yeah, definitely. And especially with Java, sometimes we forget how old Java is. I mean,
Mhm.
you have some code base from 20 years ago written in Java. Sounds like legacy. But something that I think caught my attention, and I think could be interesting for many of our listeners, is the fact that you created a manifesto that I think is
Mhm.
something that not so many out there will ever do in their life. So I was curious if you could share us, the motivation for which you created the manifesto, how you got the idea of starting this, and of course, then we can focus on the meaning and the content of it.
The Mechanized Mending Manifesto was an effort for me to put a stake in the ground on behalf of legacy code menders going into the AI age. I know a lot of us were looking at this very skeptically, as well we should, and seeing the limitations and understanding like, well, if this can, if I'm a specialist in evolving old systems and you're giving me these tools that just only work writing some new single file of code, which was what was true, most of 2023, um, this isn't really applicable to me. But obviously it was going somewhere. It was definitely going to have some sort of an impact, and I at once wanted to encourage the AI people to think about more of this legacy code knowledge base that had been accumulated by people like yourself, you know, and also to signal these legacy mentors to say like, hey, you have a stake in this AI race. Like, we should get in the game and help educate them about what this trade is really about. Um, I was basically, I was hoping we could steer the ship a little bit and be able to, if we're going to try to revolutionize software development with AI, can we do that in a way that is informed by how we see the profession? Um, and then maybe we're going to have better outcomes. Maybe then we're going to be making tools that can help us care for old systems instead of tools that just help us add to the pile.
Makes sense. But uh, if I remember correctly, you mentioned these AI people, while today you're chief architect of a company called
Yeah,
Olens AI. So I guess you join that group. So maybe can you tell us more about what you're doing at Olens AI?
that's right. So, and at the time, and it was the same month GPT-4 came out when I originally wrote mechanized mending manifesto. Um, and it was almost a year before there was significant traction that I was seeing to the idea that old code even exists within the space of AI coding. I was following it very closely, and it was seen as just like, well, LLMs have trouble with large contexts, so we're just not going to think about it right now. They were making demos and they weren't making dev tools. And then coding agents that used large language models in combination with algorithms, uh, you know, began to be able in very measurable ways to navigate legacy code bases. We have benchmarks like SWE-bench that establish, that it can solve tasks at the level of a repository. Um, and so I was starting to see, a lot of what I was calling for, this very principled application of coding agents to legacy code bases. And I was cheering these efforts on last year um, a lot. And ultimately, the winner in the open source area, I think, has been de facto. I said this before I joined them. Open Hands, made by All Hands AI, which was really originally called Open Devon. It was kind of launched as an open source response to the Devon agent, and yeah, that's where I find myself now. And it has been kind of this interesting straddling the fence between the legacy code community and the AI community, because there's really like there's a bit of a divide still. A lot of different values, and I think we have a lot to learn from each other.
Oh, definitely. And sometimes it seems that most of these tool support in development are tailored are TypeScript developers or Python developers, while you work with maybe,
Mhm.
I don't know, RPG or PL1 or even just Java, maybe there is not the same level of support.
Yeah, and there was a recent benchmark for people who are in the weeds here. Um, there was a multi SWE bench. The SWE SWE bench was the uh, first major benchmark to establish kind of these whole code repository level tasks, being able to accomplish those on agents. And multi-SWE bench came out in the last couple weeks, which is an example of, okay, now we have examples in not just Python but Java, but C and C++, even some older languages, and you can go through and see, oh, this agent is performing this well on the tasks that were selected in these different languages, and so you can kind of evaluate, and it gives evidence to what you're saying about, like, they're much better at Python. Just training data, the kind of quirks of history, the AI research community has just given the agents more training in that area, right? And so you can see as soon as you go to Java, the performance drops off. You go to an older language, it drops off still. But I'm pleased to say that the Open Hands agent that we're working on is at least less lopsided than the others so far. There's a lot left to go.
Yeah, and maybe as something that maybe is obvious to most listener, but maybe not to everybody, is how incredibly different is the number of open source projects available in languages like TypeScript or Java compared to open source projects written in legacy languages. Like if you go
Right.
on GitHub and look for RPG projects, maybe you will find one or two. So that's must make more difficult to work on such tools.
Yeah, absolutely. And there's other ways than languages that the LLM training data is going to be limited. That's a big one. Is the open source software obviously out there is disproportionately represented in how we train AI agents, or train the AI models that the agents are based on. If I'm being precise, but also open source software is different in character in other ways. You need maybe tools that work on your corporate code bases, and they have lots of internal quirks. They are not just in a language that we might not have trained on. They also have um, uh, all these proprietary systems. So how do we adapt these, things that are based on these are called foundation models, which are trained on just sort of like, some subset of the whole internet, into contexts where there's all this stuff that is just very peculiar to your local enterprise. And there are answers to these questions, but it's a very hard problem.
Oh, yeah, no, that's interesting. So if I understand correctly, you're talking about creating tools that take into account not just the knowledge available on a certain programming language, but the specificity of how we use that language within our company, maybe.
Yeah, to give an example about it, let's suppose the task at hand is like, well, we need to send the customer an email. Okay, well, if you ask ChatGPT, hey, I need a script, like it can be in Java to send the customer an email. It's going to do something that is not the right thing for you to send an email. Maybe you use a provider to do that. Maybe use some messaging service like Twilio, or maybe you have an internal SMTP server and it needs to be logged somehow. Like there's going to be lots of specific conventions around how you do any little thing that make it play well in your environment. And we need the tools not to just be constantly steering you away from your internal code standard, right? It needs to be steering you toward it.
Yeah, makes sense. Even the different the difference between different domains, like I guess your security requirements are very different if you're writing an application to play Sudoku or medical software. So maybe yes,
Mhm. Yeah, and I think
something
you deal with a
tailored.
lot of these same challenges, doing these initiatives like converting RPG to Java, maybe, and other things. Like one client says they want to convert RPG to Java, and they maybe need very different Java to come out than the next one.
Yes,
You would be able to tell me more, but I would assume that's the case.
yes. A simple example is how you deal with arithmetics because arithmetics on certain machines like the AS400 works differently. And maybe the native arithmetics you have most other platforms. So sometimes you want to emulate the arithmetics that you had on the original system if you're dealing with financial software. But in
Hmm.
other cases, maybe you want to approximate that and make the code more understandable. So use the native mathematics available on the platform, and maybe that is a choice that depends on the domain.
Yeah, exactly. So I think a lot of the things that make coding subtle and difficult for people are also going to make them hard for LLMs, and then new ways too. So in all the same ways we underestimate the challenges for ourselves, we're doing that all over again. um, which is why I'm glad that people like you are taking an interest, because you have a perspective that's really needed in the conversation.
Yeah, for myself, I come from a background in language engineering, so
Mm.
writing parser and that sort of stuff. And I'm trying to familiarize with all the challenges that Mendels are more familiar with, and try to apply the skills to the problem. Yeah. And well, among the many things that you've done was the presentation of MentorCon, where you presented the AI coding cheat sheet. And now I know that when we are talking about AI, everything that happened 1 year ago uh, age may age not that well. So can you tell us more about this presentation and this uh, this artifact, and if you are still working on it or updating it, or if you think it's still relevant as it is?
Yeah, so I did look at it recently, and I was having a conversation with a technical coach named Emily Beisch, who is fantastic. She's got a great YouTube channel. Um, she was talking about, eventually we want to have curriculum. We want to be able to teach people about what works, what are the patterns. And that cheat sheet was my first stab at it. And essentially, the ideas are still right. Like, if you want good results with these sort of magic autocomplete boxes, then you need to kind of do two things. You need to mitigate the risk that could come from bad output, and you need to constrain, how difficult is the task you're asking it to do in its, how much context is needed and so forth. So while the tools since then have become a little bit, more capable in the amount of, um, the size of the task that they can comfortably take a crack at, or the amount of, the accuracy, the risk that comes from that, those still the biggest things you think about, is constraining that. So examples of things that were on that cheat sheet is I held like, well, it's really good at incantations. I called it like an example of an incantation is like a command line, a complicated bash command line argument, for some series of commands, or a regular expression, or LaTeX. If you format, equations in LaTeX, very strong at that because it's a simple, self-contained task. And that starts to get people thinking of like, okay, this is what I can expect to work well. And then mitigating risk has a lot to do with, okay, well, can we use static analysis like type systems? Can we use unit testing on the code we're generating? Just sort of regular ways we would increase confidence. And so I think ultimately, like, if we were to update it, it would still be developing those areas and just giving lots more examples. But it's very difficult to give people the best practices when the specifics of how the tools are used is changing like almost month to month. You know, so I think the principles are really showing that they were correct and robust. But since then, we've gone from one question equals one answer to now these agents, they take a question and they iterate on it and they run the code and they test it and they try it and they fix the errors, that come back, and the way you use it has changed drastically.
Yes, definitely. Uh, and given these tools evolve so much and change so much, would you say that you are more skeptical, or am I pronouncing that correctly, about
Mhm.
AI and having more, let's say, trust in what AI can achieve, or are you still, wondering and trying to find the right mix between not to expect too much from AI?
So I see myself as having a balanced view, but in the at least in the in the conversation in the tech industry, which is very much influenced by Silicon Valley, and lots of players that have a lot of investment dollars, behind like making these technological transitions happen. I think the hype is sometimes just to an absurd degree, to where no matter how excited I am about this technology, I I sound like a skeptic by comparison. Like like say we had just invented the relational database, you know, which is like now a fundamental component of how we design things, like, and was hugely impactful, expands the class of applications we can make and how easy it is to make them. Um, uh, Imagine a world where someone's like, you know what, relational databases are going to write the laws in the future, and relational databases are going to replace all software, and they're going to take over all professions, and like, people are saying things that I just think they have not thought through. They have not done the work to be able to back some of the things that are being said. It's just very speculative futurism. And so I do think these things have a place, but it's in the ecosystem of other types of tools where we're going to get the most leverage. And I am basically, I found the best results when we limit our expectations and we find the things it can do really well repeatably, and not just the things it could do at a demo. And then when you try it on a real example, it falls over. So I think that I've seen value in almost a pessimistic level of skepticism relative to what the hype train is. I think you can be an AI realist and still think this can help us make software and maintain it for sure. It can help us so much.
Well, you mentioned expectations, and I think, from my point of view, expectations for some people have changed since they saw AI. I think
Mm,
now people believe that everything is possible, everything is even easy, and so it's
mm,
like when you are delivering some solution, like in our case, migrations, they expect that to be trivial, to be doable in 2 weeks, just throwing some stuff into ChatGPT and copy the output. So
mhm.
have you noticed something like this? Have you noticed people having crazy high expectations about what can be done?
Yeah. And although the intensity of it is, um, it's hard to reckon with, we have seen things like this before. Anytime there is something that makes like the first 100 lines of a program really just amplifies that, people overvalue it, you know. And then you enter a 10,000, 100,000 lines later, and you realize, oh, this is actually just as sluggish as before, or worse. Like we have seen this pattern happen again and again. Now, not that like a lot of these innovations haven't been really good, but it is easy to just misunderstand the scope at which they're really going to help you. Um, and so this is again where we double down on our values, and like almost working is not almost as good as working. I'll say that again, like something that almost works is not almost as good as something that works. Something that works is almost infinitely better in many contexts is something that almost works. And these are it is subtle to take AI tools that have this inherent unreliability, you know, um, and be able to make really repeatable processes out of that. It's not impossible, but it's not the magic wand that it's going to seem like. It's only that if you're doing something very predictable and repetitive, in which case you should be abstracting on it anyway. I'm getting into the weeds, but yeah, I mean, we have to double down on our values. People are not always ready to listen, and then just listen to them. I Some people believe, in the artificial general intelligence, and this will come and it will surpass all human work. And if I'm talking to those people, then just telling them about how legacy code is important, it's not the conversation they want to have. So I just listen to them, and when they need us, we'll be ready.
Yes, and I think at least at this particular time in history, I think a lot of people are more supporters of an idea, but having valid reasons. So there are people against AI, people in favor of AI. But maybe one last question on AI, then we will move on to something else. But I wanted to ask you if there are things related to AI that you see people underestimating and things that people are overestimating. So
Hmm.
tasks that maybe are not a good fit, or
So this might be a little abstract, but one of the big trends I see, I might call model maximalism. So it's just not seeing the full context of even what's been achieved in AI, let alone in all of computer science. So an example of this would be people are very fixated on whether or not we can get large language models to reason. Um, I am kind of bewildered that we're even worried about that as a question because we have reasoning programs. We have things like theorem provers. Even like you work in language engineering, compilers do very deep reasoning. Um, we have even older AI systems like Prolog and theorem provers are heavily influenced by that. So we have all these things that can reason very precisely. And then we have LLMs that are able to deal with language in all its ambiguous glory. And I don't really understand why we're almost exclusively fixated on trying to fit a square peg into a round hole with getting LLMs to reason versus integrating them with software that can reason in a much more tangible sense. So I think the newest piece of the puzzle is exciting because it was a missing piece of the puzzle. People trying to take that missing piece and make it the whole puzzle, I think that will have bad results. Um, that's a little bit abstract, but that's like the biggest trend is just like not seeing the full context of the technology we actually have available that we can use in concert. And we saw a little bit of recovery from this in the transition from just LLM prompting to agents, the new buzzword. Like that is a step in the right direction. I think we still need to go um, far there. To give you like a little more relatable to software context, I would say that I I want to see well tested software that works well, and coding assistants don't necessarily edge you toward that unless you ask. So I've seen people use them in ways where like I'm going to ask it to help me write this test, and I know what I'm doing, and I'm going to like coax it through, giving me more well tested code at the outset of this. But if you don't know to do that, then it's just going to usually give you poorly tested code. So that is a more concrete thing in terms of right now needing to drive the best practices into it as opposed to having the tool push you in that direction.
It's uh, it's very interesting for me, this reflection on AI generated code and testing, because one of the problems we are trying to work on is the generation of unit tests for legacy code that doesn't have
Mm.
unit tests. So let's see if now, so in our case, we will only use AI to generate tests. So it's
Hmm.
the opposite of, I guess, what others are doing.
Yeah, I think that's not a bad idea. Especially for untested code. Like there's um, the book pre the AI this AI boom. There have been previous ones, but working effectively with legacy code by Michael Feathers, which you'd probably be familiar with, is a great book on like bootstrapping testability into untested code. And I think that's like if there's not already tests, like and you're using a coding agent, the first thing you should be thinking about doing is using it to backfill the tests. I think that's these kind of the rules of the game still apply. Um, and then yeah, like given that you're introducing risk by using this, like have you de-risk the code base sufficiently where you would allow an agent to be used on the code and not just generating the tests, like on the code bases you work on, like that's a really important question.
Yes, one that I'm still to work on to answer. Uh, but let's now move to something else, something that we mentioned when we were talking before starting the interview. This is your tool, Untangler,
Hmm.
that you describe as a multi-language refactoring command line tool. And I found that interesting, both because it's a refactoring tool and because it's multi-language. So I think this is a code base that, if I remember correctly, the last comments are a couple of years old. And
Mhm.
so I wanted to ask you about your experience developing this tool and if you have plans for continuing development in the future.
Yeah. So I think we do need command line refactoring tools. making ones that are really usable, it's a big undertaking. If people are interested in working on that, they should reach out to me. And reviving Untangler is an option. I'll tell you a little bit about its origin and some of the later work that came out of it, because ultimately the work continued in different forms. So um, I am a big fan of refactoring automation to begin with, which by which I mean things that do like syntax transformations on existing code in certain predefined patterns. In particular, Untangler was created to perform, an automatable cross-language way. Um, Starting with the core refactorings, which Arlo Belshi calls them the core six, but it's simply being able to extract method, inline method, and then rename stuff that has a name. Those are the main ones. If you can do just those things, just like extract a new unit of functionality and then rename stuff that has a name, you can restructure code in a wide variety of ways with high confidence without breaking it. And so that was kind of the minimal subset where like anywhere I am, I want to be able to do those things. And I also, if I'm using an AI to help me code, I want it to be able to do those things. And this is where the experience we were having in the JetBrains IDE, IntelliJ, um, like it is very good at performing these refactoring operations. It's probably the best IDE for that, but it the AI agents, even the one they later built into JetBrains, doesn't use that feature. It just uses LLM output and pastes it into the code, which at scale is hazardous. So what I wanted was to be able to have a way for an LLM agent to invoke a refactoring using a syntax transform and get out of the business of copying and pasting edits essentially out of chat gpt into the code base, uh, you know when we had better, safer ways of doing it. So that was the motivation for Untangler, is to give safe syntactic refactoring transforms, an interface that LLM agents could use, and also a person writing a script could use, but usable by both humans and other automation. um, that's just difficult for a lot of annoying reasons, because historically the IDE is where we have wanted this functionality. That is where the effort has been put building it. So I looked for ways that I could just break that out of the IDE. And um, oftentimes that means like the best way might be the most accurate way, might be like interfacing with the compiler itself. Um, there's lots of different technologies that I looked at as ways to do it, but that was the motivation. And a reliable cross language refactoring CLI was sort of the call to action there. There was lots of later work on new refactoring techniques that I explored after that as well, with formal methods and doing more advanced refactoring within a custom IntelliJ plugin. So I've got kind of um, lots of later explorations on the table, but I don't know exactly what the direction needs to be for a single implementation. I think just in the last few months, we've seen the MCP, Model Context Protocol, and that's probably the shape it would take today. Is we need to get refactoring tools into the MCP interface, and that's just because that's what people are coding to. Um, that's that's a lot. I hope that was a little bit helpful in what the context of the Untangler project was.
Yeah, no, definitely. And I encounter myself the frustration about being not always easy to access the API of a compiler. So for some languages like C Sharp, there is Roslyn that maybe expose some of the capabilities, but for others,
Mhm.
this is not the case. So you end up having to maybe rewrite most of what a compiler does. For example, just to resolve symbols and figure out that this method A, this reference to method A is connected to that definition, and
Mhm.
that is very difficult. So yes, it's something that, yeah, one could underestimate the work that goes into that. Yeah.
Yeah. Now there have been some bridges with like between language server protocol, which is used behind the scenes to, as you would know, to make a lot of editor functionality in IDEs like VS Code, and there's interfaces between that and this MCP, this new protocol that um, we're using for LLM agents to be able to invoke tools in the outside world is mostly what that's for. So that is a step in the right direction. People are now thinking in the direction that I was trying to take it, but they're using it for, just like mostly understanding for the thing, the tools that help you understand the references and so forth. And what Untangler was really trying to do is also be able to use it to edit the code, to just perform the edits, like get AI out of the business of touching the code when we can possibly avoid it if we have a safer way of doing it. So that is still not really been achieved. I think it is something we need to do. But now I work for a
So,
company that makes coding agents, so maybe we'll get a chance.
but just to be sure I understand the point. So, in your scenario, the AI will make the decision about the refactoring to be done, and then a tool like Untangler will be the one that reliably execute that decision. So doesn't just try to or hope for the best, but knows
Mhm.
exactly how to do a rename or something like this.
Yeah, I think you got it exactly right. And for the listeners, the LLM can be more reliable at suggesting a refactor than actually performing it. That has come forward a lot, but at scale in tangled contexts, I think it will always be the case that algorithms are better at manipulating code safely than neural network output, just like it's safer in most cases than a human directly typing. Um, and so yeah, the some combination of the human and the AI making the decision of what refactoring we want to do, and then the algorithm performing that code transformation. That's the paradigm shift I was hoping to see. That still has not really happened.
And well, we covered a lot of ground, but uh, one of the final questions that I would like to ask is about how to help maybe young developers that are trying to mend some large legacy code base. Maybe I'm imagining someone early in their career that is assigned to deal with a large code base. They are a little bit lost. So if you had to give a couple of advice to someone in this situation, can you think of some starting points?
Yeah, well, I mentioned the book Working Effectively with Legacy Code by Michael Feathers earlier. Another, which I happen to have in arm's length,
Ah, yes.
I don't know if we've got video, but it's Kill It With Fire
Yeah.
by Marianne Bellotti, who's one of my heroes. Um, Her and Arlo Belshi have been very influential on how I see working with legacy code. And so find your sources of inspiration. There's just a wealth of information from people like that, people like Emily Beisch, um, the Modern Software Engineering YouTube channel by Dave Farley and several others now. There's you're gonna find a lot of good stuff there. These kinds of people were the inspiration for me to start the Craft versus Cruft YouTube channel. I think we don't have enough guidance out there, but that there some of us are trying to take the charge and change that. So then to develop an appreciation for the value of the work, also to understand like I said, if it's in production, it's legacy code. Legacy means it was successful, that we need it, that it is providing value. There were people at a particular point in time that made whatever decisions they needed to make at that point, that may not make a lot of sense for you today, but ultimately this is where the value is, even if it's not as fun. And so by seeing the value, I've eventually learned to find some kind of joy in the puzzle. Almost the messier the better. Like, just to embrace the challenge of of approaching, these complex legacy systems. And so that's and then just the concrete advice maybe would be move in small steps. Don't attempt large ground up rewrites. Rewrite in small iterative passes, um, which all the sources I give you would probably advise as well. Um, but yeah, find a way you can get a small value out of or a large value out of a small change.
Makes sense. Solid advice. And now my final question is there anything that I didn't ask and I should have asked you? Anything that you want to add?
Well, I I'll mention, and maybe you'll have a perspective on it, that one of the reasons I was excited to go on your podcast was because you've worked so much with language engineering. And I actually there's a talk that I have partly written in my mind, which is called Copilot Try Compilot. And it's just I want to do an ode, an appreciation of how incredible compiler technology is. um Everything we would think about how LLMs are more efficient at spitting out code than people are, like, and that, which is true, at least if you don't consider the scope of what it can do and how accurate it is, right? Like, compilers are then much, much better even than that. So I think, like, an appreciation of really, to first approximation, compilers are the only entity that have been successful at making code. Like, we produce a tiny, tiny portion compared to how much work they're able to repeatably do, so much that we don't even think about everything they're doing. So I guess that's been a source of inspiration for me. And there's lots of things in there that you can, like, refactoring automation. It essentially comes out of doing the same sorts of things compilers do. Lots of these areas of tree transformations. It does things that I find lacking in what language models can do. So I guess I would say language engineering is it's maybe aided by AI, but it is far from obsolete. I think it may experience a golden age.
Yeah, no, I think it's interesting how uh, compilers today maybe don't get a lot of attention because they just work, and so you take
Mhm.
them for granted. So, yeah. But yeah, I would like to thank you, Ray. It has been an amazing interview, a lot of content, a lot of information, and a lot of resources for our listeners to learn more about your work. You also mentioned a lot of interesting books, so we will add everything in the description. But for now, thank you a lot.
Yeah, thanks for having me.